Very good afternoon, students.
Good afternoon.
Good afternoon, sir.
Good afternoon, all of you. So let us start the discussion. All of you can see the screen, right?
Yes, sir.
Right. So last class we were discussing about the drug target interaction. That is how drug is going to be interacting with the target molecule. Like we have seen enzymes as the drug target molecules as well as receptors as drug target molecules. After that discussion, we have been started with the next kind of acids like antacids, like therapeutically active drugs or different class of drugs which has a respect to therapeutic action. Antacid, overproduction of acid in the stomach that will cause irritation and pain. And if you look at the treatment of acidity, we have been taken NaHCO3 as well as mixture of aluminum hydroxide and magnesium hydroxide. NaHCO3 is more soluble in the stomach. Because it is soluble in stomach, it will make the stomach alkaline in nature. If the stomach becomes alkaline in nature, that can be producing more acid in the stomach, making the stomach acidic in nature. You can also take a mixture of aluminum hydroxide and magnesium hydroxide. These are the better alternatives because they are insoluble and hence they do not increase the pH over neutrality. But these symptoms or these treatments, they are only controlling the symptoms but not the actual cause. So what was the actual cause then? A chemical histamine that is actually stimulating the secretion of pepsin and HCl in the stomach. There is some chemical histamine. There is some chemical named histamine that is actually stimulating the secretion of pepsin and HCl in the stomach. So what is actually happening means we will be having the stomach wall, right? Yes or no? Like cellular membrane. This is your stomach. If you can imagine, this is a stomach wall. On the stomach wall, there's a particular chemical named histamine. The histamine is going and binding to a particular reactive site. Because of histamine going and binding to the reactive site, what is happening? You are getting out pepsin and HCl. Pepsin and HCl. This is actually happening. A chemical named histamine that is actually going and binding to the receptor present on the stomach wall. Since it is going and binding to the receptor, that binding is actually leading to the reaction and pepsin is released. Along with that, HCl is obtained. Because of that HCl, what is actually happening? The more acidity the people actually are facing from more acidity as well as more types of problems. Now what we are going to do, like what we have done earlier, is we are just reacting the HCl which is already produced with some kind of bases and making the stomach neutral in nature. But we can actually control the production of HCl if you control the binding of histamine to this particular receptor or not. This histamine is going and binding to the active site of this particular receptor. If it binds, then only the reaction happens where pepsin is generated along with HCl. If I take a drug such that this drug will actually stop the binding of histamine to the respective receptor on the stomach wall, obviously you will be having lesser amount of acid is going to be released along with lesser amount of pepsin. So in that category, whatever the drug we have, that is named as drug cimetidine. The drug cimetidine prevents the interaction of histamine with the receptor present on the stomach wall. So it will stop the interaction of histamine with the receptor present in the stomach wall. How it can stop? There are two things. One, it can be acting as a competitive inhibitor. Other, it can also bind to the allosteric sites where it can actually disturb the respective binding of histamine to come and bind to the active site. Like it can actually compete with the histamine or it can change the shape of active sites. Like that, you can actually take a drug which will disturb the interaction of histamine with the receptor present on the stomach wall, thereby lesser amount of acid will be released. Thereby, lesser amount of acid is going to be released. This was the largest selling drug in the world until other drug named as Ranitidine or Zantac was discovered. Because although this cimetidine we have taken that has a slightly toxic nature, because of that the next category of drug is Ranitidine, or it is also named as Zantac, that is also still in usage even today. Yes or no? That is also still in usage even today. So that kind of drug we are going to use. Is that clear, students? This is not controlling the symptoms. This is actually stopping the cause.
Yes, sir.
Yes, right. Very good. Then comes the next kind of drugs, antihistamines. Histamine is actually a substance which can also be actually acting as a it will be contracting the smooth muscles present in bronchi and gut. It is allergic. Because of that, you will be having the common cold. Yes or no? Nasal congestion. It will be causing lot of things. It is allergic to this. So what happens is histamine is a potent vasodilator. It contracts the smooth muscles in the bronchi and gut, and it also relaxes the walls of blood vessels. It is also responsible for nasal congestion, common cold, and allergic response to the pollen. So these are all actually caused by histamine. So in that case, it is causing a lot of diseases. In that case, what you have to take? You have to take some antihistamines. The antihistamines will stop the histamine to go and bind to the receptor, causing all these type of disadvantages or diseases. So what are the examples of antihistamines? Brompheniramine, terfidine. These are some examples. Examples of antihistamines are brompheniramine. I'll give the structure to you so that you will be having some idea. So brompheniramine, if you try to analyze the structure, you will be having CH group. Like the structure, you don't need to remember, but at least you can understand what type of functional groups are there. The structures can't be remembered, students, as I was saying. So this is nothing but your brompheniramine. It is also called as dimetrap and dimetane. And you have terfidine. Terfenadine, if you look at that structure, it will be having carbon connected to two phenyls as well as OH group, that is alcoholic group is there, and nitrogen is actually connected to 4 carbons, 1, 2, 3, 4, and the fifth one is actually connected to the benzene ring. To the benzene ring we have CH3 taken thrice C, and here we have OH group also connected. So from this you can understand the structures are not required, but what you can understand is just look at the functional groups. Yes, we have OH groups in terfenadine. Okay. So now you can ask a question, sir, if histamine is actually causing all these problems and histamine is actually causing the acidity inside the stomach, then to reduce acidity, can I take an antihistamine? To reduce acidity, can I take an antihistamine? Is that acceptable? Are you getting these points or not?
Yes, sir. Yes, sir.
The point what we have explained in acidity is histamine is actually going and binding to the respective stomach wall. Because of that binding, it is actually secreting pepsin along with that HCl. If we stop the histamine going and binding to that particular wall, the HCl automatically concentration will be reduced. Antihistamines, what they are doing? They are also stopping the respective binding of histamine to the receptor, so that all these nasal congestion, cold, and all the other kind of diseases, they are going to be reduced. But you cannot use the antihistamine to reduce the acidity. The reason is the histamine working on different kinds of receptors to produce acidity and to produce allergic action. The same compound histamine is not working on the same type of receptor. If it will be working on a different receptor to produce pepsin as well as HCl. It will be working on a different other kind of receptor to produce the respect to other nasal congestion, cold and all. That means you cannot take antihistamines to reduce the antacids because they to reduce acidity you cannot take antihistamine. You have to take antacid only. Okay. Although histamine is same compound, you cannot take antihistamine. You cannot take antihistamine to control the acidity because histamine is working on different kinds of receptors. That point you have to understand it carefully. Yeah, why going to be working on different kinds of receptors. Anti-allergic and antacid drugs work on different receptors. You may ask a question, sir, what are those receptors? That is out of your 12th standard. You're only saying the different receptor, different receptor. What are those receptors? Receptor proteins. Okay, they are macromolecules. They will be having different structure. So their structures and all are not required out of our 12th standard, but you have to understand that anti-allergic drugs and antacids, they are going to be working on different kinds of receptors. So you cannot use every antihistamine as an antacid, right? So then comes the next category, neurologically active drugs. What are some neurologically active drugs? Can anyone take an example? Like tranquilizers and analgesics. These are the neurologically active drugs. Analgesics again, non-narcotic and narcotic. Narcotic means you will be having like they are addictive in nature. Morphine, heroin, codeine. Non-narcotic means they are not addictive in nature. Let us start with one by one. Tranquilizers means what? Tranquilizer. Tranquilizer means they affect the message transfer mechanism from nerve to receptor. So tranquilizers, they actually are used whenever a person is actually suffering from depression and all. So you can also call them as like antidepressants. Yes or no? Antidepressants. So they are used in the treatment of stress, like also in the sleeping pills, they are major components. Like whenever a person has a lot of mood changes, what actually is responsible for mood changes? There is some hormone called as noradrenaline. This noradrenaline, if it is low, then the person will be suffering from depression. That means his mood will not be changing and he will also always be depressed. Okay. So tranquilizers are useful under that condition. So they affect the message transfer mechanism from nerve to receptor. They are used in the treatment of stress and mental diseases. They are obviously the essential components of sleeping pills. As I have told you, noradrenaline is a hormone which is playing an important role in the mood swings. And if there is a lack of noradrenaline, then the person will be suffering from depression, and under that condition you have to use the antidepressants. Is that point clear or not? So what is the role of antidepressant now? Antidepressants will be acting as the enzymes which catalyze the degradation of noradrenaline and thereby increasing its concentration and thus the signal sending activity. What we are saying here, if the noradrenaline level is low, if level of noradrenaline is low, then person will suffer from depression. Antidepressant drugs are required. Antidepressant drugs are required. So what are these antidepressants going to do? Antidepressants, generally if you take noradrenaline, it will undergo degradation. It will undergo degradation. If you take these antidepressants will act on those enzymes which catalyze the degradation of noradrenaline. Antidepressants will act on those enzymes. Antidepressants will act on those enzymes which catalyze the degradation of noradrenaline. Degradation of noradrenaline. You are understanding the scenario or not? The noradrenaline is a hormone which is actually degraded inside a human body by some types of enzymes. Yes or no? There are some enzymes which are actually useful to degrade this noradrenaline. Antidepressants will be acting on those enzymes which are catalyzing the degradation of noradrenaline. That means if some person is disturbing you, you are disturbed by some person. As a teacher, I want to protect you. Imagine the case. Then I'll be controlling that person who is disturbing you, so that you won't be get disturbed. Same thing happening. Noradrenaline is degraded by some enzymes. The enzymes are biological catalysts. They are catalyzing the reaction of degradation of noradrenaline. Now what I want to do, if noradrenaline concentration is low, we'll suffer from depression. I want more noradrenaline, more means not greater, in the permissible limits. If I want that noradrenaline in the permissible limits, what I have to do? I have to stop the degradation of noradrenaline. How I can do that? I have to control these enzymes. That means I am not, whatever the antidepressant I am going to take, that will go and bind to the enzyme. It won't allow the noradrenaline to go and bind to the enzyme, so that the catalytic activity will happen. Antidepressant will act on those enzymes which catalyze the degradation of noradrenaline, and thus maintaining good concentration, and thus maintaining the required concentration of noradrenaline. Understood these points or not?
Yes, sir.
Right, very good. Example you can take. Now we have understood how these antidepressants are going to be working out. What are the examples? Iproniazid and phenelzine. These are two such drugs. Iproniazid and phenelzine, they are the two such kind of drugs. And we also have some mild tranquilizers. Whenever a person suffers from tension, then you will be having the mild tranquilizer. And Equanil, there was another kind of chemical or medicine which is used to control the hypertension and all. So I have to remember these names, students. There is nothing to be derived here. We can't derive that. If someone asks a question which is a mild tranquilizer, you have to answer it is chlorodiazepoxide and meprobamate. Okay, you have to remember this. And Equanil, that is used to control the depression and hypertension. These are the different types of antidepressants for different categories. And also we have barbiturates. The barbiturates, they are also like derivatives of barbiturate acid. They are called as barbiturates. They are also used as this respective tranquilizers, and they are also sleep producing agents because they are the major components in the sleeping pills. Barbiturates, as I was saying, important. These are important class of tranquilizers. They are derivatives of barbiturate acid are called as barbiturates. Examples you can take: Seconal, Vernol, Amital, all those comes under this category. Veronal, Amital, Nembutal, Luminol, and Seconal. Structures not required, but you have to remember the names at least. And barbiturates are hypnotic. Hypnotic means what? They are actually sleep producing agents. And some other substances used as tranquilizers are Valium and serotonin. So all these are working under the same category. What was the category? There was a particular hormone called as noradrenaline, whose concentration which will actually degrade in the human body. The degradation of that particular noradrenaline is catalyzed by different enzymes. If the enzymes are catalyzing the degradation greatly, its concentration will be reduced. If its concentration is reduced, obviously a person will suffer from depression. To the antidepressants, whatever we are going to take, they will go and bind to the enzyme which is catalyzing the degradation, not the They will not allow the noradrenaline to go and bind. That is why never overthink on anything. Okay, you should never overthink, because the habits whatever we are going to develop, because you may ask a question, sir, why the enzymes are produced, why the degradation of noradrenaline is more, because such kind of enzymes are high. Why are they produced? Because our activity only, because our process of thinking only. So you should maintain your body in such a way, you should be having a healthy physical health as well as a mental health. You should be very strong. You should never think of your result which is going to happen after few days, not only today, even in future also. You might be doing some projects earlier, yes or no? So you should never think of your result and all, and don't get worried. Only think on the day-to-day activity and only try to improve yourself. Never compare with other. Okay, that was the best advice one can give to yourself. So we have to maintain our life to be in such a way such that we are always healthy physically as well as mentally. And depression, lot of youth nowadays is suffering from depression. Why? Because of the way the lifestyle has been changed and all. And this was the chemistry behind it. And these are the respective antidepressant drugs for different category. Like for tension, we have different drugs. For mild tranquilizers, we have different categories. And what are different barbiturates, that is derivatives of barbiturate acid. All those are going to be acting as a tranquilizers. They are all sleep producing agents. Right, students? Then let us go with the next kind of neurologically active drugs, that is analgesics. Analgesics, they are all like painkillers. Like if we are getting pain, we can't be sustaining pain for longer time, so that has to be reduced. So in that category, we have some specific kind of drugs. So those drugs are said to be like analgesics. They reduce pain without causing mental confusion. Your pain has to be reduced. That doesn't mean your mental condition has been disturbed or your nervous system has been disturbed. No, you have to reduce the pain without causing any other mental confusion, unconsciousness, paralysis, or other disturbances in the nervous system. No disturbance should be caused to the nervous system to reduce the pain. Yes or no? So analgesics are those drugs which are helping in this activity. We will be having different types of pains. And in this analgesics, we have two categories, that is non-narcotic or non-additive. They are non-addictive drugs. They are not addictive in nature, non-narcotic. If you look at this category, aspirin and paracetamol are non-narcotic analgesics. That means they are going to be acting as the analgesics which are not going to be addictive to you. They are not addictive to you. Aspirin, what is the role of aspirin? The aspirin will be inhibiting the synthesis of chemicals. There are some chemicals which are going to be synthesized, known as prostaglandins. Those prostaglandins, they will actually stimulate the inflammation in the tissue and cause pain. What is going to happen? There are some chemicals known as prostaglandins. They will actually stimulate, they will actually cause the inflammation in the tissue as well as in the respective body and cause the pain. So aspirin, if you take, that aspirin will be inhibiting the synthesis of chemicals. What type of chemicals? Prostaglandins, which are stimulating the inflammation. If those chemicals have been reduced, obviously the inflammation will be reduced. Obviously will be coming out of the pain. Yes or no? And there are some drugs which are actually useful in the not only reducing the pain but also reducing fevers. If a drug is used in the reduction of fever, it is said to be antipyretic. And because of its the aspirin also has the blood clotting action. Okay, like anti-blood clotting action. Because of its anti-blood clotting action, the aspirin will be also used in the prevention of heart attacks or preventing the coagulation of respective platelets. So let us understand this. Aspirin and paracetamol are non-narcotic analgesics. So this is what I'm talking about. There are some chemicals known as prostaglandins, which actually stimulates the inflammation in the tissue and cause pain. So aspirin is going to reduce the chemicals, thereby reducing the inflammation caused. And these drugs are effective in relieving the skeletal pain such as the arthritis. And these drugs have many other effects such as reducing fever, antipyretics. Because of its anti-blood clotting action, aspirin finds its use in prevention of heart attacks also. These are all the usages of respective aspirin. And we also have some narcotic analgesics. What are the narcotic analgesics I have told you? Like they are
Morphine,
addictive in
codeine.
nature. And morphine, heroin, codeine. What was the structure of those? Morphine and many of its homologs, when administered in medicinal doses, they also relieve pain and they also produce sleep. Yes or no? And in poisonous doses, they will form different types of diseases like convulsions, coma, and they may also ultimately lead to death. Morphine narcotics are sometimes referred as opiates. Why? Because they are obtained from opium poppy. And these analgesics are chiefly used for the relief of where extreme pain is there, like a post-operative pain, cardiac pain, terminal cancer, and childbirth. Whenever there is an extreme pain, then only we are going to use these kind of drugs, that is narcotic drugs. Examples are morphine, heroin, and codeine. And what was the structures? In the morphine, you will be having respective like phenyl groups are there. Here we have a phenyl group, and one more phenyl group is present. And here you will be having with this nitrogen, that means that the stereochemistry has been mentioned over there. And here you have OH. Here also you have OH. If it is morphine, you will be having both sides OH. Both sides OH means morphine, like both these carbons. OAC means that is said to be heroin. Everything is same, just instead of OH, you will be having OAC and OAC. Codeine means you will be having OCH3OH. Okay, these were the respective structures of morphine, heroin, and codeine. With respect to these structures, you can analyze. Examples of narcotic analgesics are morphine, heroin, and codeine, and they are also going to be useful in the reduction of pain whenever the extreme pain is there. And in medicinal dose only they have to take, and only suggested by doctors, not by any other individuals. And they are addictive in nature as well. Is everything clear, students, so far?
Yes. Yes, sir.
Yes, right. Very good. These are your respective neurologically active drugs. Try to answer this question. Ranitidine, Vernol, phenelzine, Equanil. Like if you look at the ranitidine, it is nothing but your respective antihistamine. Vernol, B,
Barbiturate.
Vernol. It is nothing but a barbiturate. Phenelzine is a tranquilizer. Equanil is a carbamide derivative. So AQ, BR, CP, DS. Then comes the next category of drugs known as antimicrobials. Microbes means what? Like antimicrobials means you have antibiotics as well as antiseptics and disinfectants. Antibiotics again bactericidal and bacteriostatic. Bactericidal means killing effect. Static means controlling or stopping. Antiseptics and disinfectants also you'll be having. So first let us start with antimicrobials. Antimicrobials, drugs used to destroy or prevent development or inhibit the pathogenic action of microbes. That means that there are some foreign molecules like bacteria or fungus or virus which will be entering into your body, and because they enter the body, they will be having respective action. Like if you have a viral fever, some virus has been entered your body. If you have any bacteria entered in your body, that may be causing different kind of disease to you if it is dangerous. And the drugs you have to take, those drugs which will destroy or prevent the development or inhibition of these pathogenic action. So they are going to be respect to antimicrobials. So they are the antimicrobials will not be having the or will not be relying on the effect whatever it is produced by microbes, that will be immediately stopped either by killing them or by stopping them. Bacteria, whenever a bacteria entered, you need to have antibacterial drugs. Fungi entered, antifungal, antiviral, as well as antiparasitic drugs. So different types of drugs are there. And in our category, we will be studying about antibiotics. Okay, in our category, we will be studying about antibiotics. What are antibiotics? They are used to treat infections because of their low toxicity for humans and animals. What are these? First of all, you need to understand. As I was saying, they are antimicrobials. If you look at antibiotics, antibiotics are the substances which are produced by microorganisms and they will inhibit the growth of them. Like, understand the scenario. If you look at antibiotic students, the production of antibiotics, like if you look at the revolution that has been given by penicillin, like Alexander Fleming, but the synthesis of that particular penicillin, like to do the clinical trials and all, it took over 13 years and all. So how that idea will come to you? Like how do you know that if I do these particular chemicals, they are going to be acting as an antibiotics? How do you know that? First idea was the microorganism which enter the body, that itself is releasing the chemicals which is stopping the growth of microorganism. So people started studying those particular chemicals released by the microorganism which will stop their growth. The microorganism, whenever it enters the body, that itself is producing the chemicals which is stopping the growth of the microorganism, which is stopping the action of the microorganism. So whatever the antibiotic we have to prepare, that antibiotic should be having the similar structure to this particular chemical. So people started studying the chemical structure of these particular substances which are released by microorganism to stop their growth. Everyone understood this point or not?
Yes.
Yes or no? Antibiotics are those substances which are actually produced, okay. In the initial days, the study started like antibiotics are those which are actually produced by microorganism to stop the growth or their activity. So there was some scientist known as Paul Ehrlich. He actually prepared a medicine named as Salvarsan. How did he prepare? By looking at the chemicals, by studying the chemicals which are obtained by the release of microorganism to stop their growth. He was successful in preparing some antibiotic known as Salvarsan, but which was toxic, because in Salvarsan we have arsenic linkage. Like Salvarsan will have this structure, like we have phenyl group, arsenic, double bond arsenic. Yes or no? Phenyl group, OH, NH2, NH2OH. So this is nothing but your Salvarsan, which is actually prepared or synthesized by a scientist named as Paul Ehrlich. But this Salvarsan is actually having a good effect, and it is used for the disease like syphilis. It is active against that particular disease, and it is also toxic to the humans. Okay, but the toxicity to humans, whenever you look at the toxicity nature, Salvarsan is actually more toxic to the pathogens which enter the body when compared to the human beings. Since there is no other option, the people have at that time has used them. And to reduce the toxic nature, what he tried to figure out is the arsenic double bond arsenic linkage in sulfurson is that similar to the N double bond N linkage in the azodides? Yes or no?
Yes.
There is an N double bond N
Yes.
linkage in the azodides, so he tried to replace that arsenic double bond arsenic linkage in the sulfurson with the N double bond N linkage, so that you can actually produce a more easier and simplest drug. So this was the idea. So in 1908, Paul Ehrlich was as a scientist who prepared a medicine for syphilis known as arsenophenamine or sulfurson. Sulfurson has arsenic double bond arsenic linkage like N double bond N linkage of azodides, and that's why he started working on germs like color of azodides on tissues. In again 1932, he also developed first effective antibacterial agent prontozil similar to the structure of sulfurson. Like if you look at the structure of prontozil, it will have a similar structure to that of sulfurson, but the arsenic double bond arsenic is replaced with N double bond N linkage. But actually, what is happening is in the human body, the prontozil, which has similar structure to sulfurson, that is actually converting into a compound called sulfanilamide. What people thought earlier? People earlier thought that people earlier thought that sulfurson is actually acting as an antibiotic. Sulfurson is actually acting as an respective antibiotic. But what was the issue with that? It is toxic to human beings. Yes or no? It is toxic to human beings. So that is why he prepared, like he want to replace the arsenic double bond arsenic linkage with N double bond N. And he was successful in preparing the respective sulfurson, respective prontozil from identifying sulfurson. But in the human body, this prontozil actually converting into respective sulfanilamide. That means the actual compound which is actually stopping the growth of microorganism or inhibiting them or destroying them, that is actually the sulfanilamide, not the prontozil or not the sulfurson. Everyone understood this logic or not?
Yes.
The sulfurson is a compound. How it is prepared? By studying the structures of the chemicals which are produced by microorganisms which are killing them. There are some chemicals which are released by the microorganisms which are actually killing the microorganism back. So these chemicals, by looking at the structure, he prepared a chemical known as sulfurson, but it was toxic to humans also. So to reduce the toxic nature, he started studying the azodides because N double bond N linkage will be there, which will be non-toxic to humans. But actually inside the body, this prontozil that is converting into the sulfanilamide, which is responsible for the inhibition of the microorganism. So this will be the leading discovery of all the sulfur drugs. So sulfur drugs were being discovered in this fashion. In 1929, penicillin is discovered by Alexander Fleming from the fungus Penicillium fungus. You can see how the discovery of the drug has been obtained, how the discovery of an antibiotic has been done from the respective fungus only, from the respective pathogen only. We don't know how the structure is because they are very complex molecules, right? How can we prepare that complex molecules maintaining the stereochemistry at every carbon atom? That is only possible when you try to understand the structure. We are understanding the structure of that particular chemical obtained by the pathogen only. By studying those chemicals only, we are doing the research and producing different chemicals or modifications has been done. And penicillin is actually discovered by Alexander Fleming, and ampicillin is a modified form of penicillin. Nowadays also we all use ampicillin. Amoxicillin, you use or not? Nowadays also, if you get any viral fever or cold fever or any throat infections, we will be using the amoxicillin. Most of us will be using amoxicillin only because that will be acting as a broad spectrum antibiotic. It will be active against many types of bacteria, many types of gram negative and gram positive bacteria. So this is all about your antibiotics. Antibiotics have two types of effects. This is all about the preparation or synthesis of antibiotics. And if you look at the effects, antibiotics have two types of effects. What are those? Cidal means killing effect. The antibiotic can kill the respective microorganism which is present in the body, or static, that means inhibitory effect. It can reduce the effect, or it can stop that effect of the microorganism instead of killing it. That is, they are bactericidal as well as bacteriostatic. And you have to remember the examples in each case: penicillin, aminoglycosides, ofloxacin. These are all the respective bactericidal. That means they will kill the microorganism which was present. Erythromycin, tetracycline, chloramphenicol, they are respective bacteriostatic. Chloramphenicol gives in case of typhoid, dysentery, acute fever, urinary infection, meningitis, pneumonia. And antibiotic disidaziline, that is toxic towards strain of cancer cells. These are the different uses of different kinds of antibiotics: bactericidal antibiotics, bacteriostatic. And which antibiotic is used against what type of disease, that you have to remember only. Chloramphenicol, that is useful about all these type of diseases: typhoid, dysentery, acute fever, urinary infection, meningitis and pneumonia. Antibiotic named disidaziline, that is actually toxic towards the strain of cancer cells. Is that clear, students?
Yes,
Yes.
sir.
Yes, right. Very good. Antibiotics are actually like broad spectrum, narrow spectrum, and limited spectrum. Broad spectrum antibiotic means kill or inhibit wide range of gram positive and gram negative bacteria. Wide range. If a particular antibiotic is actually active against wide range of gram positive and gram negative bacteria, then it is said to be broad spectrum. Narrow spectrum means effective against limited gram positive or gram negative bacteria. Limited means effective against a single organism or disease. And examples, if you look at the narrow spectrum, you have penicillin G. In the broad spectrum, you will be having ampicillin, amoxicillin, chloramphenicol, ofloxacin, vancomycin. So these are all the different examples in broad spectrum and narrow spectrum, and no examples as far as your 12th standard for the limited spectrum antibiotics. You don't worry with that part. Penicillin is a narrow spectrum antibiotic. It is not effective over a broad range of bacteria. It is only effective over a small range. Broad spectrum is ampicillin, amoxicillin. Those antibiotics which are using still today, they are actually the derivatives of penicillin, and they are actually the broad spectrum antibiotics. Right, students? Chloramphenicol, isolated in 1947, is a broad spectrum antibiotic. It is rapidly absorbed from the gastrointestinal tract and hence can be given orally in the case of typhoid, dysentery, acute fever, certain form of urinary infections, meningitis and pneumonia. These are all the same diseases. Vancomycin and ofloxacin are other important broad spectrum antibiotics. The examples you can remember all the broad spectrum. The antibiotic disidaziline, that is supposed to be toxic towards certain strains of cancer cells. These are the uses, and which antibiotic is actually against which type of disease, that points have been mentioned here. As I was saying, you have to know and remember these things. And if you look at the structure of penicillin and sulfaperidine, sulfaperidine is a sulfur drug. Sulfur drugs has been discovered with the conversion of protosyl into sulfanilamide in the body. Actually, the protosyl, which has N double bond and linkage, that is actually converting into sulfanilamide, which is leading to the stopping or inhibiting the action of microorganisms, and that is where the discovery of sulfur drugs has been started. That is where the discovery of sulfur drugs has been started. If you look at penicillin, the penicillin will be having this type of structure. You can look at the structure of penicillin, how complex it is. Yes or no? A 4-membered ring and a 5-membered ring, both are fused with each other. At every carbon, we have to maintain the stereochemistry and all. So that is why penicillin was a very complex structure. It is not easily prepared, and you have to to obtain penicillin so that you can use that in the use that for the clinical trials, because before naming it as a respective antibiotic, you have to perform the clinical trials and all. So to obtain sufficient quantity of penicillin to perform the clinical trials itself, it took 13 years. 13 years it has been taken to produce that particular penicillin or synthesize it at that time. Among the following, the narrow spectrum antibiotic is? Try to answer this.
Penicillin G.
Penicillin G. Amoxicillin is broad spectrum antibiotic, bacteriostatic, synthetic modification of penicillin 1 and 3 both.
1 and 3.
1 and 3 both, because it's a broad spectrum antibiotic, and as I have told you, it is a modification of penicillin, amoxicillin. So 1 and 3 both is the right answer. Which of the following is not true about chloramphenicol? Which of the following is not true about chloramphenicol?
First option.
It inhibits the growth of only gram-positive bacteria. Is that true? No.
No, sir.
So obviously not true means option 1 is going to be the right option. Right, students. After we have studied antacids, antihistamines, neurologically active drugs like tranquilizers and analgesics, narcotic, non-narcotic, and after that we have seen antibiotics. Then comes the next last category, antiseptics and disinfectants and anti-fertility drugs. Like if you go with the antiseptics, they are also coming under the antimicrobials only. Antiseptic means chemicals which either kill or prevent the growth of microorganism, which will kill the microorganism or prevent the growth of microorganism. Antiseptics are applied to living tissues such as wounds, cuts, ulcers, and diseased skin surface. Like furacin, soframycin, Dettol, these are all your respective antiseptics. And if you look at CHCl3 pure, that will react with AgNO3 or not? If you take pure CHCl3, there won't be any reaction, no reaction. If you take CHI3, if you try to react, if you take the pure CHI3, you treat with AgNO3, reaction occurs or will not occur? Reaction occurs. The same we have studied in the haloalkanes. Why? What was the reason? Ci bond is weaker than CCl. That is why CHI3 iodoform will be having the respective antiseptic properties. It is also used as antiseptic. Iodoform, iodine is a powerful antiseptic. Boric acid in the dilute aqueous solution, that is also the antiseptic. Bithionol added to the soaps for the antiseptic property. There are many antiseptics. Okay, so chemicals which either kill or prevent the growth of microorganisms. Antiseptics are applied to living tissues such as wounds, cuts, ulcer and diseased surfaces. Bithionol or bithionol, you don't confuse like it is alcohol and aldehyde. No, the name has been pronounced in both the ways. Bithionol will have this type of structure. This was the respective structure of bithionol. It is also called as bithionol. Bithionol is added to the soap for the antiseptic property. Iodine is a powerful antiseptic. 2 to 3% of iodine in alcohol water. That is that mixture is called as tincture of iodine, that was even applied on the wounds. Iodoform CHI3, that is also used as antiseptic for wounds. Why? Because in iodoform the carbon iodine bond is a weaker bond and that can be easily broken to produce iodine, which has the antiseptic properties. H3BO3 boric acid in the dilute aqueous solution. Okay, dilute aqueous solution is a weak antiseptic for eyes. Boric acid in dilute solution, that is also going to be the respective weak antiseptic for your eyes. Is that clear, students, so far?
Yes, sir.
Yes.
Then comes the disinfectants. What are disinfectants? So these antiseptics we are applying on the living tissues, but disinfectants we will be applying on the floors, on the like non-living systems. The same substance can be acting as an antiseptic as well as disinfectant. How? By varying the concentration. Like we can take 0.2% phenol, that is an antiseptic. 1% phenol is a disinfectant. Chlorine in low concentrations in aqueous solution. To inanimate objects like floor, drainage system, instruments. Same substance acts as antiseptic and disinfectant, both by varying concentration. Like 0.2% phenol antiseptic, 1% phenol disinfectant. And if you take chlorine concentration like 0.2 to 0.4%, like 0.2 to 0.4 ppm parts per million in the aqueous solution, and SO2 in very low concentration, they will also be acting as disinfectants. Disinfectants, they are applied to inanimate objects like floors, drainage systems, and instruments. They are not applied to the surfaces like living tissues. Right?
Yes, sir.
Right, very good. Then comes the anti-fertility drugs. Like with the development of antibiotics, earlier people used to suffer from one kind of disease or other kind of disease. No one is going to live longer. But with the help of these antibiotics, the lifespan has been increased. Because of that, more and more population, because of that, anti-fertility drugs, they are also a need. Birth control pills, they will contain mixture of synthesis estrogen and progesterone derivatives. This progesterone that is suppressing the ovulation, and we have norethindrone and noestrol. There are two kinds of derivatives. Like what are those derivatives? Like norethindrone, if you take, it is a synthetic progesterone widely used as anti-fertility drug. If you take norethindrone, in norethindrone we'll be having what type of functional groups? You'll have C triple bond CH group. You will have alcoholic OH. You will have alcoholic OH, and you will also be having respective C double bond O group. C double bond O group. Norethindrone is a synthetic progesterone or a derivative of progesterone, widely used as anti-fertility drug. And if you take a noestrol, this is actually an estrogen derivative. It is also called as ethinyl estradiol, and it will also have your respective C triple bond CH. It will also have respective alcoholic OH, and it won't have C double bond, or rather it has phenolic OH also. So in noestrol we have alcoholic OH, phenolic OH, and C triple bond CH. In the norethindrone you have C triple bond CH, alcohol, and C double bond O. That means I can say if I do different types of reactions, noestrol which possesses phenolic OH will be reacting with FeCl3 to form a violet colored complex, whereas norethindrone will not react. Yes or no? Phenolic OH, wherever it is there, phenols and derivatives of phenols, they will be reacting with FeCl3 to form respective violet colored complex. That is actually a confirmatory test or detection of phenolic OH. Whereas norethindrone, which do not have phenolic OH, it will not be reacting with FeCl3 to form a violet colored complex. Is that clear? Such type of questions you can also expect from the structures of the respective anti-fertility drugs. And norethindrone is a synthetic progesterone, whereas noestrol is a estrogen derivative. And it is used in combination with the progesterone derivative, and that will ultimately suppress the ovulation. Mixture of chloroxylenol and terpinol, that will act as
Antiseptic.
antiseptic. Very good. This was asked in NEET 2017. Such type of questions you'll get. Bithionol is generally added to the soaps as an additive to function as
Antiseptic.
antiseptic. Okay, so these are the different categories of drugs so far we have studied. So all these drugs, whatever we have studied so far, they are going to be useful in your drugs and medicines. Like chemistry in everyday life, we will be studying with respect to three perspectives: the chemicals in the drugs and medicines, the chemicals in the food, and the chemicals involved in the cleansing action or cleansing agents. The first part, like chemicals, whatever we have in the drugs and medicines and their actions and their activities we have seen. Now we look at the different types of chemicals which we will have in the food. And if you look at the chemicals present in the food, artificial sweetening agents, food preservatives, antioxidants, food colors, fat emulsifiers and stabilizing agents, flour improvers, anti-staling agents and bleaches, nutritional supplements such as minerals, vitamins, and amino acids. So these are the different kinds of chemicals which you are going to be which are going to be present in your food. Out of all these, only thing which is supporting to nutritional value is the vitamins, minerals, and amino acids. Only this is actually supplying to the nutritional value for a human being, but remaining all the artificial sweetening agents, food preservatives, antioxidants, food colors, flour improvers, fat emulsifiers, and stabilizing agents, these are used to either preserve the food or make it look beautiful or make it more tastier. Okay, only few of it have the nutritional values, whereas remaining all chemicals in the food, they do not have the nutritional values. Rather they are just used to actually enhance the taste or enhance the beauty or just preserve the food item for longer time. Okay, we'll start with the few of the chemicals which we have in our syllabus, like artificial sweetening agents, food preservatives, and antioxidants. We'll be studying only about these three. Artificial sweetening agents, natural sweeteners, example sucrose, adds to calorie intake, and therefore many people prefer to use artificial sweeteners. Whatever the natural sweetener you have, that will be actually adding to the calorie intake, and that is why people are choosing the other path where there is no calorie intake but sweetness can be sensed. So that is why artificial sweeteners have been used. And the first type of most popular one is saccharin, orthosulfobenzimide. Orthosulfobenzimide is also called as saccharin, is the first popular artificial sweetening agent. It was around 550 times as sweet as cane sugar. Like if you look at the properties of saccharin and all, orthosulfobenzinamide, also called as saccharin, is the first popular artificial sweetening agent, 550 times as sweet as cane sugar. It is excreted from the body in urine unchanged. That means however you take the respective saccharin, that is coming out of the body from the urine without having any change. What do you mean by that? That means it is not actually metabolized in the body. Yes or no? That particular saccharin is not metabolized in the body. It appears to be entirely inert and harmless when taken. It is almost inert, not reacting with any species present inside the human body. And its use is of great value to diabetic persons and people who need to control intake of calories. If you want to control the intake of calories, you can use this particular respective artificial sweetener. Right, students? We have different other artificial sweeteners also, like we have aspartame, sucralose, allitame. Okay, we look at the studies of those. Aspartame is actually it is one of the most successful and widely used artificial sweetener, and it is roughly 100 times as sweet as cane sugar. It is a methyl ester of a dipeptide formed in the reaction of aspartic acid and phenylalanine. And if you look at the most important part, use of aspartame is limited to only cold foods. that is, and in cold foods and soft drinks only, we have to use this aspartame because it is unstable at cooking temperature. Because it is unstable at the cooking temperature. We have OH, C double bond O CH2, CHNH2, C double bond O NH, CH, CH2 PH, C double bond O CH3. If you look at the aspartic acid part, this is the acidic part, and this is your phenylalanine part. This is nothing but your aspartic acid part, and the other part is nothing but phenylalanine part, methyl ester. And we also have an amide linkage. This is C double bond NH is the amide linkage. And we have finally ester group, C double bond OCH3. It is an ultimately methyl ester or not? It is a methyl ester. C double bond OCH3 is a methyl ester. And it is only used to cold foods and soft drinks because it is unstable at cooking temperature. At cooking temperature, what happens? The bond cleavages will happen and it will lose its activity. And which chemical or which sweetener is stable at cooking temperature is sucralose. Sucralose is stable at cooking temperature and it also do not provide calories. Allicin is a high potency sweetener. Although it is more stable than aspartame, the control of sweetness of the food is difficult while you are using it. It is approximately some 2000 times as sweet as your cane sugar. When compared to cane sugar, it is 2000 times sweetest. Sucralose is a trichloro derivative of sucrose. Sucrose means what? What type of linkage is there in sucrose? Sucrose.
Glycosidic linkage.
Yeah, what is
Glycosidic.
glycoside linkage between which type of monomers?
Alpha glucose and beta fructose.
Okay, C1 of alpha D glucose with a
Into
C2 of
Wow.
beta D fructose.
Beta.
Okay, this is a glycose, and between these two monomeric units, between C1 and C2, we have the respective glycoside linkage and sucrose is formed. And what is sucralose? Sucralose is a trichloro derivative of sucrose. Whenever you have respective sucrose and you try to replace the OH groups from 3 carbon atom positions with the chlorine groups, and that trichloro derivative, whatever you are going to obtain, that is nothing but your sucralose, and it is stable at cooking temperature and you can use it. We have chlorine present here, chlorine present here as well as here. Yes or no? Sweetener value in comparison to cane sugar. So with respect to cane sugar, if you take aspartame, it is 100 times sweetest. Saccharin, that will be 550 times. Sucralose is 600 times. Allicin is approximately 2000 times. Very, very sweet in nature. Allicin is highly sweet in nature. Next comes the concept of food preservatives. What are your respective food preservatives? Generally, in your day-to-day life, what are the food preservatives you can have? Like not the chemicals which you will be using in your cooking, right? You might be knowing cooking or you have seen cooking. The table salt which you are going to add, that is a food preservative. It preserves the food. The oil, you can just look at the curry made out of less oil, very less oil and more oil. More oil is not useful, but it will be useful in saving the food for longer time. It will preserve the food for longer time. The most commonly used preservatives are like table salt, vegetable oils, and sodium benzoate, that is used in limited quantities. Sodium benzoate is also acting as a food preservative, and that is used in limiting quantities and is metabolized in the body. Okay. Food preservatives, then comes the concept. Food preservatives prevent a spoilage of food due to microbial growth. It will be preventing the spoilage of food due to microbial growth. The most commonly used food preservatives include table salt, sugar, vegetable oils, and sodium benzoate, C6H5CONA. Sodium benzoate is used in limited quantities and is metabolized in the body. And salts of sorbic acid. Sorbic acid is a 6-carbon carboxylic acid with 2 double bonds. It's a 6-carbon carboxylic acid. With the 2 double bonds. Salts of sorbic acid and propanoic acid are also used as preservatives. These are the respective food preservatives which you have. That means they are helping in actually protecting the food from the microbial growth. Antioxidants in food. So these are also helping the food preservation. How? By retarding the action of oxygen on the food. The oxygen is going to be acting with the materials present in the food. In the food, there might be different kinds of materials. Those materials may be reacting with the oxygen present near the food, and they can be forming different other substances. So antioxidants, whenever you take, they will actually preserve the food by retarding the action of oxygen on the food. And what are the most famous antioxidants? Anyone knew? Butylated hydroxytoluene BHT, butylated hydroxyanizole BHA. So these are some of BHT, BHA. They are some of the respective antioxidants. And we'll also have some citric acid. Like if you think of citric acid, where is it majorly found? Can we found citric acid in lemon?
Yes, sir.
So whenever you add lemon to the food material, it will stay longer if you observe. Okay, because that acts as an antioxidant. Okay, the most famous antioxidants are butylated hydroxytoluene and butylated hydroxyanilone. Addition of BHA, butylated hydroxyanilone, to butter increases its shelf life from months to years. If you add the BHA to butter, you can use that butter to years as well, because it is now having an antioxidant. So oxygen cannot be reacting, or the action of oxygen on the food is not there. Sulfur dioxide and sulfate are useful antioxidants for wine and beer, sugar syrups and curd, peeled or dried fruits and vegetables. For these kind of items, sulfur dioxide and sulfite, they are actually useful as antioxidants. And sometimes BHA and BHT along with citric acid, they are also added with the citric acid to produce more effect. These are the respective antioxidants, and you have to know their usage. As I have told you, this is all about remembering only, mostly the chemistry in everyday life. We have been understanding the chemistry wherever required. Yes or no? Like how the action is going to happen, how the drug is going to perform, what is the interaction and all. The uses and the respective examples, we have to remember. There is no other option. Okay, everyone has to remember. Even I have to remember before coming to the class what type of drugs are there, how are they useful and all. Usage we can't derive, right? It is not something derivable, not a mathematical equation to solve. But these are all scoring chapter, students. You will never miss out any question if you get it from like biomolecules, chemistry in everyday life, polymers, environmental chemistry. So from all these chapters, whatever the questions you are expecting, you will never mistake any question if you read them perfectly. If you read the concepts given in the NCERT and the Allen module perfectly, you will never miss out a single question also. Try to answer this. Artificial sweetener, which is more stable under cold conditions only, is
Aspartame.
aspartame. These are all the different types of chemicals which you have seen in the food so far. Now the chemicals in food and soap and detergents, like food materials, cleansing actions or cleansing agents, drugs and medicines. These are the three actions where drugs and medicines and food materials we have seen. Now the cleansing agents. In this section, we will be learning about detergents. What are detergents? Soaps and synthetic detergents we have now. So soaps and synthetic detergents, how are they going to be useful? So detergents are of two types, soaps and synthetic detergents. Two types of detergents are used as cleansing agents. These improve cleansing properties of water. These help in removal of fats which bind to the material, which bind other material to the fabric. Like to the fabric, you can have some oil binded. I have to remove that oil. How that can be done? When I apply this soap or synthetic detergent, that can be done. And what is the mechanism behind the cleansing action of soaps and detergents?
Micelle
Anyone know?
formation.
Micelle formation, very good. Okay. How is micelle is going to be found? We'll be understanding. So soaps, if you try to think about soaps, what are soaps? Soaps contain sodium salts. Soaps containing sodium salts are formed by heating fat. How? With the NaOH solution. And this reaction is said to be nothing but saponification. If you look at the details clearly, soaps containing sodium salts are formed by heating fat, that is glyceryl ester of fatty acids. We'll take a fatty acid now, glyceryl ester of fatty acid. We'll heat that with a aqueous sodium hydroxide solution OH minus, and we'll produce the respective soap. And this reaction is nothing but your saponification. Only sodium and potassium soaps are soluble in water and are used in cleansing properties, used in cleansing purposes. Only sodium and potassium soaps are soluble in water. Why? Because the solubility depends upon what factors? Solubility depends upon hydration as well as hydration,
Charge density.
which depends upon charge density. The Na plus K plus ions, they are going to be soluble in water. Because of that only, they are going to be acting as respective respective cleansing purposes. Those soaps of sodium and potassium. And when you look at sodium and potassium, which is even more useful, which are even softer to skin when compared to, like, so potassium soaps are even more softer to skin when compared to sodium soaps. Generally, potassium soaps are soft to skin than the sodium soaps. And if you look at the mechanistic approach, glyceryl ester of stearic acid or fat, you treat with NaOH. So can I call this total bulky group as some R group? I have RO, C double bond O, C17H35. We are treating this with NaOH. OH minus will be acting as a respective nucleophile now. It is not acting as a base because there is no acidic proton. It is acting as a nucleophile because there is an electrophilic carbon. OH minus will try to attack this particular carbon. The C double bond of pi electron density moves away. And what is going to happen in the first stage? You will have RO, CO minus, COH, C17H35. Negative charge on oxygen comes into the carbon oxygen bond leaves. You will be getting RO minus plus C double bond O, OH, carbon connected to C17H35. RO minus will try to pick up this proton to forming ROH and C17H35, C17H35, C double bond O, C double bond O minus. This will develop electrostatic force of attractions with the Na plus ions if you have taken Na plus, and K plus ions if you have taken the respective KOH. So again in the R part, you have R is nothing but what? This is all bulky group. R is connected to OH. This R means CH2OH, CHO, C double bond O, C17H35, CH2, O, C double bond O. O, C double bond O, C17H35. This will again react with the one more OH minus or not. So like that, you will be generating C17H35, C double bond O minus Na plus. This is nothing but your sodium stearate because we have two more molecules. They will again react to convert two more molecules of C17H35CO minus, which is nothing but sodium stearates. Along with that, you will generate CH2H, CHOH, CH2H, which is called as glycerol. It is a nucleophilic addition. It is just a nucleophilic addition by addition elimination type. Nucleophilic substitution. OH minus has been substituted, OR is lost, right? Nucleophilic substitution by addition elimination type. Substitution by addition elimination type. Right, students? So that is how you can actually prepare the respective soap, and this mechanism for this reaction is a nucleophilic substitution by addition elimination type, and this is nothing but saponification, where soap has been prepared, sodium stearate. And what are different types of soaps you can have? Stearic acid. From the stearic acid you can form stearic acid. We can also form from palmitic acid. You can also form soap from oleic acid. From these kinds of acid, like respective salts, sodium or potassium salts of these acids will be acting as soaps. Sodium or potassium salts of these acids will be acting as respective soaps. Is that clear, students?
Yes, sir.
Yes, sir.
Yes, right. Very good. Which of the following is not a soap? Sodium acetate, sodium palmitate, sodium stearate, sodium oleic.
Sodium acetate.
Sodium acetate, because palmitic acid, stearic acid, oleic acid, from those acids, whatever the salts you are getting, they are acting as soaps. Sodium acetate is not a soap. Next, if you look at why do soap not work in hard water? Why they are not going to be working in hard water properly? Why do they not work in the hard water? In the hard water, we will be having what type of ions? The hardness of water is due to presence of what type of ions?
Magnesium, calcium.
Mg+2, Ca+2 majorly. So those respective sodium or potassium salts of respective stearic acid or oleic acid or palmitic acid, they will be reacting with the Mg+2 or Ca+2 ions, and they will form different other salts like C17H35CO- will be forming a salt with Ca+2, which will be insoluble in nature. So the hard water will be having Ca+2, Mg+2 ions. They will be reacting with the ions of respective sodium stearate or sodium palmitate or sodium oleate, and they will form the insoluble salts. These insoluble salts, they will be separating as scum, and they are not useful as the useful for the cleansing purposes. Like hard water contains calcium and magnesium ions. These ions form insoluble calcium and magnesium salts or magnesium soaps respectively when sodium or potassium soaps are dissolved in hard water. These insoluble soaps separate as scum in water, and they are useless as the cleansing agents. Like if you take C17H35CO- Na plus MgCl2 or CaCl2, like we have C17H35CO- ions will be having electrostatic force of attraction with Ca+2. Two such ions will have CO- C17H35. So that type of soaps are going to be insoluble. The solubility again depends upon hydration enthalpies and all. Because they are insoluble, they are not going to be useful as cleansing agents, because they will be separating as scum. Because they have good electrostatic force of attraction, so why they will break this attraction and develop a new attraction with water? So they are not going to be developing a new attraction with water, so that is why they are not so soluble, because the already present attraction with Ca+2 and C17H35CO- is great. That is why they are not going to be working in the hard water. And the whole mechanism for the formation or for the cleansing action of soaps is micelle formation. What is micelle formation means? Micelles are also colloids. What type of colloids micelles will come under? Micelle formation, if you look carefully, let us take some water. Let us take some water and try to add a soap. Let us take some water and try to add a soap. In the soap, we have what? Like if you take C17H35CO minus, C17H35, C double bond O minus. In this, which is the hydrophobic part? C17H35 is hydrophobic or not?
Yes, sir.
CO minus is hydrophilic.
Philic.
So now I have just taken this water bottle and I am adding the soap molecules, like I am adding soap. So what happens is, in the soap we have hydrophobic. Hydrophobic means water hating. That means this long chain is not a water loving, it is water hating. That means it is not going to develop new interaction with water. But throughout the bottle we have water. Only on the surface we have, like there's a possibility that the hydrophilic will be lying on the surface and hydrophobic will be present in this manner. If this molecule comes into the water is surrounding the hydrophobic pulse also, which are repelling or not. So whenever I try to add soap molecules to water, what happens is the molecules of soap or the ions of the soap, they will be present on the surface in such a way such that the negative charge of COO minus that will lie on the surface, that is hydrophilic part, they will develop new interaction with the water. Hydrophobic will be projected out. Hydrophobic will be projected out. So like whenever I'm adding soap, all the molecules are occupying the surface. Until how much condition this scenario will be present in this manner? If I add soap, they will all occupy the surface. If I further add soap, they will also occupy the surface. Further addition of soap, they will also occupy the surface. If I am continuously adding the soap, then all the surface points will be occupied or not at one stage.
Yes,
At one stage, all the surface points are going to be occupied. There is no surface point to be occupied by soap molecule. Then what happens? They are forced to go into the water. They will now go into the water at a specific concentration. What is that concentration? Known as CMC, critical micelle concentration. Under that CMC condition, what is going to happen? All these soap molecules will be forming the respective micelles in this fashion, such that they will form a spherical micelle where you will be having the hydrophilic part surrounding. A hydrophilic part will be present on the surface of the micelle, whereas hydrophobic long chains will be projected inside the top micelle. They will be free again from the electrostatic attractions with water. So that is how micelle is going to be formed. And we have a fabric. This is my fabric where there is a dust particle. Okay, some oil is present here. This is oil. What happens is whenever I add soap, that soap will be actually forming a micelle. Okay. Micelle formation. When like this my fabric, my t-shirt, on my t-shirt some dirt is there, so then I will be rubbing with soap. What happens? There is a formation of micelle. Now this micelle formation, in the micelle formation we have hydrophilic part outside or not? Hydrophobic will be holding the respective oil. This all hydrophobic parts will be oil, holding the oil droplet, and all the hydrophilic, they will be surrounding outside. They will be present outside. Now if you try to wash that area or wash that part of the fabric, what happens is water is flown. In water we have partial negative and oxygen, partial positive and hydrogen. The partial positively charged hydrogen present in water, they will try to attract partial negatively charged oxygen from this, or the hydrophilic part will be developing new electrostatic force of attraction with delta plus. Thereby the micelle is actually forced out, forced to come out from that particular area. But what is micelle holding? Micelle is actually holding the oil droplet. So the oil droplet is actually forced to come out of that particular area. That is how dirt is going to be removed. Is that clear, students?
Yes.
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 Yes or no? So that is how the removal of dirt is going to happen. And this is how the micelle formation is going to happen. The same cleansing action of soaps and detergents is just due to the formation of micelles. And these are nothing but your colloidal chemistry. Colloid and a solution. What is the difference between a colloid and solution? Just the particle size. In solution, the particle size is very small. Colloid, the particle size lies between 1 to 1000 nanometer. In the suspension, the particle size is greater than that. Okay. And next we have synthetic detergents. We have anionic, cationic, and non-ionic detergents. We'll discuss those synthetic detergents in the next class and then start with the new chapter named as environmental chemistry. Fine, students. Thank you all, everyone. Bye.
Thank you, sir.
Thank you.
Thank you, sir.
Thanks, sir.